Hi there everybody, today we're going to look at drawing line graphs, alright. Well, we're not going to look at drawing, we're going to look at interpreting as well, but essentially we'll start with drawing them. So the purpose of a line graph really is kind of a representation of data again, and normally in terms of a timeline, so you can see the changes over a period of time. So that tends to be the case of why you would draw a line graph, to represent something changing over a period of time. It doesn't have to be, but it tends to be, alright. So there we go. So a unit of time goes along the x-axis. Obviously that's trying to give us an idea of obviously something progressing over a period, and then the variable will turn to go onto the y-axis. All right. So the points are plotted like normal coordinates, and they are therefore, because it says draw a line graph, they're joined with straight lines. All right, not curved lines, straight lines. Okay, because it was based on specific measurements. So here we go. So this table shows the highest temperature each day in a city over a course of a week. And it asks you to draw a line graph to represent that data. All right. So first things first is that obviously we need to put our axes on, label them up, and then consider obviously how we go about doing this. Well, later, just look at the numbers look at the dates basically. So I've got Monday to Sunday along the bottom, so that should be relatively straightforward, Monday to Sunday, and then on the top it'll go from the lowest being 14 all the way up to 26. So I need a scale in here to kind of represent that. So it needs to go up to 26, doesn't it? All right, so between 0 and 30 should do it, and going up in 5s. All right, so some increments in there. All right, and then at this point, because I'm taking measurements at specific points, then of course I just need to mark them on where it actually is. So for example, well, I might as well do it now. Well, let's get them labelled first. So we've got those two at the bottom, and now we're going to plot them. So Monday is going to be 15, so that's going to go there. All right, so that's the first one. Tuesday, which is going to be this one, is going to be at 19, so it's going to be about there. And then Wednesday is going to be at 26, so it's going to be about there. And then Thursday at 23, so it's going to be about there. And then the Friday at 16, so that's 15, so we're about there. And then what are we on Saturday at 20, so that's going to go over there. And then Sunday at 14, so that's going to go about there. All right, so there we go. So there's our points plotted. Making sure obviously the gaps are nice and even, because we are talking about time. Obviously Monday, Tuesday, Wednesday, a day apart, so the gaps in between them need to be consistent. And then of course we just kind of put the line in between them. All right, so there you can see there's our line graph. Relatively straightforward stuff. Okay. Right, so let's have a look at interpreting one. So here's a line graph showing the average temperature in March in a city. And again, it would be surprising much that you see something very, very similar to this. It's something, basically a temperature changing against a time. It seems to be a kind of commonplace, a common thing to use, so you can see what's happening. So you can see, hopefully, that around about 2013, obviously the temperature's quite high, and in 2014, obviously quite a bit of a drop. Okay. So let's have a look. So which year had the highest temperature? Oh, well, we'll just explain that one. It's one where the peak is, so 2013. Let's have a look at the next question. What was the average temperature in 2010? So how are we going to work out the average temperature in 2010? Well, the line graph shows the average temperature. So it literally is just a case of read that one. So that's going to be 4, that's going to be 6, so it's got to be 5 degrees. Okay. All right, I thought that might trick you out there. We said average. No, it actually says in the question average temperature, so we don't have to do anything. And how much hotter was it in 2012 and 2014? So we need to work out the difference in the temperatures between 2012 and 2014. So 2012 is going to give me 8. That's that one there. And then at 2014, well, I'm guessing that's around about 1. Maybe something even less than that. It's about half, but I don't know, about 1. So let's estimate 1. So 8 and 1, so the difference is going to be 7 degrees. All right, so there we go. So 2012 was 7 degrees hotter than 2014. All right, so when reading the graph, and you can probably see my kind of slight concern here is where that number is. All right, so just go with what you think is best, and as long as you're writing down what you've done. So here the idea of saying 8 degrees for that one, 1 degree for that one, really should have written 8, take away 1. Then of course we're still looking to kind of pick up the marks even if we've misread it, but obviously in this case we've done it right. All right, well that's line graphs in essence. Please visit maths-school.co.uk for some additional practice on some questions, but of course you're more than welcome to obviously revisit this video at any time. Thanks for listening.